Hello, Assalamu alaikum. Welcome to the course of Engineering Mechanics. I am Azan Ahmed, graduated from University of Engineering and Technology, Peshawar, Pakistan. I have studied civil engineering during my undergraduate studies, and here I will be teaching you the course of Engineering Mechanics. The book which I recommend is Engineering Mechanics by J. L. Merriam and G. Craig, which is published by one of the famous publishers McGraw-Hill. So let's get started. Bismillahirrahmanirrahim. Actually, I have divided this course of engineering mechanics into different modules, and each module is covering a chapter in the book which I already mentioned in the first slide. In this module 1, we will be trying to know what are some of the key fundamental concepts that we need to know before formally starting the course of engineering mechanics. Like if I say what does we mean by engineering mechanics, how it's going to be different from other branches of mechanics, the different laws of motion, that is the different laws of mechanics actually, and many other things. So let us start with the introduction to engineering mechanics, which is going to be our first lecture. Now you might have heard and you might have memorized different definitions of mechanics in your school or college physics. Like somebody says mechanics is that branch of physics which deals with the motion and the cause of motion. Now I don't wanna prove it wrong, but the thing which I wanna tell you is that this definition fits with the sub-branch of mechanics called as kinetics, which comes under the umbrella of dynamics. Actually, in physical sciences, we study different systems or bodies. So a body may be subjected to load or force, but still there would be no motion. Now such kind of physical science is called as statics, which is again a subdiscipline of mechanics. So in that way, the definition which I was talking about is not suitable for mechanics. Now what actually is mechanics? So it's a physical science in which we consider bodies under force and we want to know what is the effect of that force. Now that effect may be motion, that may be displacement or some kind of stresses which we will be talking about, or some kind of strain in the body, or it might be an internal forces, as we will be talking about all of these, so there is no need to worry about all these things. So mechanics is the branch of science which deals with the effect of forces on bodies. So if you look at the image which is on the left side of your screen, here we have a weight which is suspended to a cable, and those cables are then suspended from a roof or something like that. So this weight is basically a force. So weight is what? Weight is actually a force. Now this weight is producing some kind of internal forces which we call as tension in case of cables. So this weight is basically producing tension T1 in the first cable, tension T2 in this cable, and tension T3 in this cable. So these are what? These are actually the effects. These are actually the internal forces which we call as effector. And how this is came? This came from this weight, which is basically the force. Similarly, on the right side, we have another image which is basically a beam. So a beam here is subjected to some kind of load. That may be snow load, wind load, earthquake load, or any kind of load, or maybe it's the self weight of the beam. So then this beam has deflected. It has changed its shape due to this load. So this change in shape is basically the effect of this load. So deal with such kind of things in mechanics. Similarly, in this slide we have two pictures in which I have tried to explain what we basically study in engineering mechanics. So in the top picture we have some water in a container and a piece of wood is floating while the piece of steel has sunk in the water, as you can see over here. Now why does this happen? It is because water applies a force on external bodies which we call as buoyant force, or we call them as the upthrust force. This phenomena was explained by Archimedes, and this principle is known as Archimedes' principle. that if the weight of the material we drop in water is less than the force which is acted upon by water on the body, then the body will basically float. But if the weight of material which we drop in the water is more than the upthrust force, then the body will sink. So these all are studied in mechanics, or more precisely in fluid mechanics. Similarly, in the bottom picture, we have a tendon or foot of a person. When a person walks, then a reaction force is applied by ground on his thumbs due to weight of the person's body. Now, due to the reaction force, some internal force will be produced in his tendon, or we call them bones, as well as some turning effects which we call as torque will be produced. So these are the effects which we studied in these courses of mechanics. Now, if we talk about the classification of mechanics, so mechanics is broadly classified into three branches based upon the body on which the force is acting. So we have engineering mechanics, also called as mechanics of rigid bodies. We have mechanics of solids, and we have mechanics of fluids, or fluid mechanics. So in engineering mechanics, we basically consider rigid bodies. What is rigid body? A rigid body is one which doesn't deform, or which doesn't change its shape, or which doesn't change its size under the action of force. And that's why this branch is also called as a rigid body mechanics. So it is that branch of mechanics in which we study the behavior of a rigid body under the action of applied force. And as I told you before about rigid body, so any body which doesn't undergo deformation, change in strength, or change in shape, or change in area under the action of force is said to be rigid body. Actually, this is an ideal term, and generically there is no rigid body on the planet Earth. But in order to understand the more complicated problems and deformable body mechanics, we first of all need to study and learn the analysis of rigid bodies. So that's why we study this branch of mechanics. And in this playlist, I will be uploading videos related to the rigid body mechanics. Now, the another branch of mechanics is the mechanics of solids, also called as deformable body mechanics. Now, in this branch, we deal with internal forces, which is the result of an external force. We see how are they distributed. For example, if we talk about beam, then we draw shear force and bending moment, which shows the distribution of internal forces, which we will be seeing in mechanics of solid. Now, these internal forces cause stresses, which is basically internal forces per unit area. So, if the internal stress at some point, for example, in a beam is more than the strength of the member or material, then the material has chances to get failed or even collapse. So these internal forces causes deformation and stresses. So if we are dealing with such system which deforms or change shape, length or size, etc., we said that body is deformable body. For example, in this picture, we have two beams. One is considered as rigid, and the another one is considered as deformable. The right side, because that one has got deflected due to suspended weights. So the third branch of mechanics is fluid mechanics based upon the body which force is acting. In fluid mechanics, we basically deal with the behavior of fluid when it acts by forces. So fluid is basically anything which can flow. That is to say, gases and liquids are fluids. So we analyze different types of fluids system basically. So the mechanics of fluid is the branch of mechanics that deals with liquids or gases. The study of fluid mechanics will be studied in courses called fluid mechanics, hydrology, and other relevant subjects. Now let's talk about the classification of mechanics based upon the response of a body or a physical system against the applied force. So mechanics is broadly classified as static and dynamics. So if the response of a system, that is to say the velocity, displacement, internal forces, etc., if these responses does not vary with time, that study comes under the statics. But if the response of a system is varying with time, we say that this branch of mechanics is dynamics. So a study of such systems in which the forces or causes of motion is continuously changing with time. So they comes under the umbrella of dynamics. Also, there may be a third type of class of mechanics in which the force acting on the system neither static completely nor completely dynamics, but in between them. And we, for simplicity, assume that the acceleration is zero, due to which no dynamic effect is producing. So we consider it as static. For example, all kind of structural systems or buildings are under quasi-static state. So there is always some kind of dynamic loads acting on them. For example, wind load, earthquake load, although they are very small, due to which we consider them as static. So in this class of mechanics, the dynamic load is acting, but it is at very slow rate. Now, dynamic is further classified as kinematics or kinetics. In kinematics, we do not consider the forces causing motion, but rather we deal with motion parameters, for example, displacement, time, speed, etc., without considering or without taking into consideration the cause of the motion. For example, there is one famous equation of kinematics, that is S equal to VIT plus half VT squared, that you may have studied in your school physics. In this equation, we do not consider the force. So this equation comes under the kinematics. While in kinetics, we consider the cause of motion. For example, R the Newton laws, so they comes under the kinetics. Finally, if we talk about why engineering mechanics is so important to study, so the answer to this is that besides its application to real life problems, it is the prerequisite for most of the subjects that we study in civil engineering. For example, mechanics of solid, structural analysis, force control design, steel structure, structural dynamics, earthquake engineering, geotechnical engineering, foundation engineering. So we will be inshallah making playlist for each of them. And if you would like, please request it to subscribe my channel and press the bell icon for more videos. So meet you in next video.